All right, guys, let's get to our next lesson. This is going to be 8.4, area of regular polygons. So this one you probably did not do in middle school. So just a quick review on what a regular polygon is. Most of y'all remember it's when all sides are going to be congruent as well as every angle. So these are little pictures of regular polygons. Okay, so there's 3 different ones. So let's talk about the parts of a regular polygon. We are going to have a central angle that we're working with, okay? And the reason why we call it a central angle is if you remember back to our little unit of circles. See if I can get this. But there we go. This is when if you have a circle and if you draw from the center and 2 radii, which are the blue diagonals, okay? So I'm going to go ahead and label those as a radius. A radius are all the segments that go from the center to the edge of a circle, which you'll notice it does exist in the polygon. So we will identify some segments in a regular polygon as a radius because the circle is always circumscribed about a regular polygon, okay? Because on a regular polygon, everything is congruent. So that's a central angle. You might need to use that. And then this orange segment right here is going to be called an apothem or an apothem. However you want to say it is fine with me. This is important. It goes from the center of the polygon and the circle, and it is perpendicular to an edge, okay, which will also make the point right here a midpoint. So if you want to put tick marks right there, put tick marks right there, because that apothem always goes to the center of one of the side lengths, okay? So that right there we sometimes refer to as S, the side length, okay? The apothem is there. We have a central angle, and then we have a radius. Okay, so I'm going to remove the circle because we don't always need that, because we're not ever going to always have the circle drawn on a regular polygon. We'll just see it like this. Okay, but you can see that if I add the circle, you can tell how that is a radius. Okay, and that's a central angle. All right, so let's discover the formula. So I'm going to do a little investigation where you're going to find it on these 3 regular polygons, and then we'll fill out the table. So it says draw the pentagon, which I think I drew for you. And this is divided into congruent triangles. So that means draw in the radius. Okay, so draw in 1, 2, 3, 4, 5 radii. So draw in all radii. And then it says, what is the area of one isosceles triangle in terms of A and S? Okay, so A is going to represent the apothem. So when I draw that red segment right there, that's representing my apothem, little a. And then I said S represents the side length, so we're going to identify the bottom side to be the side length. Remember, all of these are the same, okay? So if I find the area of this one triangle right here that I just highlighted in red, then that's a pretty simple formula that we just learned from the last lesson. It's 1/2 base times height, okay? Or base times height divided by 2. So I'm going to write it over here off to the side. The base is S, the height is A, and then we're going to divide that by 2. So that's the area of one of these isosceles triangles. Now, what do you know about all 5 of these isosceles triangles? All 5 of these are the same, okay? So we have 1, 2, 3, 4, 5 isosceles triangles. So if I want to know the area of all of those triangles, that's going to represent the area of that whole entire pentagon. So all I have to do, since there are 5 isosceles triangles, all I have to do is multiply this times 5. Okay, let's try one more time, or 2 more times over here. So if I draw in all the radii, in fact, I'm just going to draw 2 so I can focus on just the triangle. Here's my apothem. Here's my side length. Remember, all of these are represented by S. Sorry, my stylus doesn't write very good on this pad. And if I do the same formula, apothem times, actually I want to write it the other way. This is my apothem. I'm going to do base times height, which is S times A divided by 2. How many triangles would we have in this hexagon? 1, 2, 3, 4, 5, 6. So we would need to multiply this times 6. All right, one last time for this heptagon over here. The apothem goes straight down the middle. The bottom is going to represent S. All of them represent S. And the area of one isosceles triangle is base times height divided by 2. How many of these triangles do we have? We have 1, 2, 3, 4, 5, 6, 7. So I'm going to times that by 7. Okay, so the area of any regular pentagon is 5 times S times A divided by 2. For any hexagon, it's 6 times S times A divided by 2. Heptagon, 7 times S times A divided by 2. You see the pattern? 9 times S times A divided by 2. 12 times S times A divided by 2. N times S times A divided by 2. Okay, now I'm going to highlight this right here, and I want you to tell me what this represents. Right here, 5S, 6S, 7S. Okay, what does 5 times the side length represent? What does 6 times the side length represent? What does 7 times the side length represent? What does N represent? N times the side length represent? Okay, that represents perimeter. Okay, so that right there is actually the perimeter. Okay, that right there is the perimeter. 7S is the perimeter. So this right here is represented as the perimeter. N times S is simply just the perimeter. So the way we want to write this formula out for any regular polygon is perimeter times the apothem divided by 2. Okay, I think on the formula chart, if you have yours, you might see it written as apothem times perimeter divided by 2, or 1/2 apothem times perimeter. Okay, so any of those work. Okay, that's the formula you'll need to use to figure out the area of a regular polygon. Okay, so let's do some examples now. So all I'm given here is the apothem. Okay, and so here's where it gets tricky. If I only have the apothem, I need to know what this side length is, so that way I can represent it in the perimeter, because it's 1/2 perimeter times apothem. Okay, actually I wrote that backwards. I usually write it the other way. 1/2 apothem times perimeter. Okay, but it doesn't matter. You can interchange those. So how do I figure this out? Well, you probably want to draw in a radius, because then it's going to it'll create a right triangle. Now remember, these two are congruent. But then you say, well, I still don't have enough information because I can't do Pythagorean theorem. Yes, but you did learn that this angle right here and this angle, actually all of the angles are congruent, and you know how to find the sum of the interior angles. The sum of the interior angles is 540 degrees. So when I divide that by 5, each interior angle is 108 degrees. Well, every radius always bisects the angle. So this little angle inside the right triangle is 54 degrees. Okay, so what can we use? We can use trig to figure out this little piece right here. Then we can just double it to figure out the side length. So opposite and adjacent is what I have. So I'm going to use tangent of 54 degrees equals opposite over adjacent. So I need to use my calculator to figure this out. I have 14 on top, so I'm going to do 14 divided by 54 degrees of tangent. I'm using my iPhone calculator. So this little piece right here, which I represented as x, is 10.17. So I'm going to hit times 2 in my calculator to represent the whole entire side. So S, this whole entire side, is going to be 20.34. Okay, so 20.34. So now I can use that to figure out what the perimeter is. So I'm going to just, since I have the whole number in my calculator, I'm just going to hit times 5. So the perimeter is 101.72. So here's what I'm going to enter in my calculator. 1/2 times 14, which is the apothem, times 101. And I lost my calculator. 101.72. Okay, so since I still have that long number in my calculator, I'm going to go ahead and times it by 7 because half of 14 is 7, and that's going to be my final answer. So the area, a little squished here, the area of this is going to be 712.01. So I'm going to go ahead and box that final answer right there. And this is, do they give me a units? No, so this is just units squared. Okay, so let's try another one. This one's a little bit different. On this one, they gave me the radius. They didn't give me the apothem, but what can we do? We can draw in the apothem to make another right triangle, okay? So for the hexagon, each angle is 120 degrees because if I take 720 degrees, that's the total measure of all the angles, and I divide it by 6, I get 120. So what does that do to this angle right here? That makes that little angle 60 degrees. Well, if you have a good memory of a 30, 60, 90 triangle, because that's what this is, that's a 30-degree angle, and that's a 60-degree angle. This 7 is the hypotenuse. So if you have a good memory, this piece right here is the short leg, which is always half of the hypotenuse. So if that's 7, then that means this is 3.5, which is, this is 3.5. That makes all the sides 7. So this is a good little quick way to remember, only for the hexagon that is, that all of these triangles inside the hexagon only, they're all equilateral, okay? Because the radius was 7, this side is 7, all of the radii are 7. So that's something to remember for a hexagon only, okay? So that's 7. Now, the apothem is what we really need because that's in our formula. Well, if this little piece right here is 3.5, sorry, you can't read my handwriting too much, 3.5, that means the apothem is 3.5 radical 3. Okay, 3.5 radical 3. If you want to use trig, you can use trig. Now, I will say this, on the homework, I'm having you leave some of the answers in radical form. Okay, so let's practice leaving this in radical form. So I have 1/2. Apothem is 3.5 radical 3 times the perimeter, which 7 times 6 is 42. Okay, so here's a quick way to multiply and leave it in radical form. Multiply 1/2 times 3.5 times 42. Okay, so I know half of 42 is 21, so all I have to do on my calculator is times 21 by 3.5. Remember, you can always pause this video. So 73.5 radical 3 on, let me plug my calculator. 7.5 radical 3 is the area of that hexagon. And this is in units squared. Okay, one more. This is a regular quadrilateral, which is known as a square. Now, a square is also like a rectangle, so if we can figure out the base and the height, we just have to do base times height. You don't have to do 1/2 or apothem times perimeter divided by 2. So the question is if I can figure out this piece right here, well, that's the same as this whole entire side, which is a square, so that's going to be the same on all sides. So if I can figure out that side, then all I have to do is times it by itself, and that'll give me the area. So how do we figure this out? So the apothem is a 45, 45, 90 isosceles triangle. So if that's a 45, 45, 90, you should remember that the hypotenuse, we just have to divide it by radical 2 to figure out this side length right here. Okay, so I'm going to take 3 radical 5 and divide it by radical 2. Okay, and that's remembering for an isosceles triangle. Okay, if you don't remember how to work with the isosceles right triangle, you need to go back and look up that formula. Okay, and I'll draw it right here off to the side in green. This is your formula that you have already learned. That's x, and that's x radical 2. Okay, that's for all isosceles right triangles. So if this is supposed to be x radical 2, I just need to divide it by radical 2. Okay, so let's figure out how to change that. I have to multiply it by radical 2 over radical 2, which gives me 3 radical 10 over 2. So guess what, guys? This right here is this piece right here. Well, I need to double that so I can have the whole entire side. So what is this times 2? Let me get a different color. So if I times that by 2, what do you get? Oh, the 2's cancel. The 2's cancel out. So guess what the side length is? The side length is 3 radical 10. Well, if that's 3 radical 10, then this is 3 radical 10 because this is a square. So all you have to do to figure out the area is 3 radical 10 times 3 radical 10. You've multiplied that before earlier this year. So 3 times 3 is 9. And radical 10 times radical 10 is 10, which is 90. So the area of that square is 90 square units. So let's try one last problem. It says find the approximate length of each side of a regular 20-gon, okay, so a really big, large regular polygon, if A equals 80 and the area equals 20,000, okay, 20,000 square feet. So what you want to do is just use algebra and solve backwards. So I have 20,000 equals apothem times perimeter divided by 2. So if I can solve for the perimeter, all I have to do is divide that by 20 to get that. So I'm going to reduce that right there. 2 goes into 80 how many times? 40 times. So that's a 40. And then I want to divide by 40 to cancel that out. And I got to divide this side by 40. So how many times does that go into that? 20,000 divided by 40 is 500. So 500 is the perimeter. Well, if the perimeter is 500, and this has 20 sides, I'm going to take 500 and divide it by 20. So divide that by 20 because it's a 20-sided polygon. And so that means each side length is 25 feet. And that's using the formula.